Welcome to Tomorrow Unveiled, your essential guide to navigating the future. Have you ever thought about a world where advanced robots aren't just, stuck on assembly lines, but are agile enough to play soccer or perform with musicians, maybe even get this, enroll in a PhD program? Well, get ready. Because this past week, specifically July 29th to August 5th, 2025, our dedicated research team, they've identified something huge, a real pivotal inflection point in humanoid robotics.
Yeah, absolutely. What we've seen, it's not just like small steps forward. This week feels like a definitive shift where all that theory, all the breakthroughs we've been tracking, suddenly they're becoming, well, tangible. And that's leading to widespread commercial deployment of humanoids. It's happening.
And that's exactly what we're diving into today on Tomorrow Unveiled. Our mission here is to cut through all the noise, all the hype, and bring you the really critical, cross-corroborated insights. From that mountain of research our team pulled together, we want to explore why this moment is so crucial, how these machines are evolving, and maybe more importantly, how they're set to integrate into our lives. So what actually makes this specific week an inflection point?
Well, for decades, the dream of truly adaptable humanoids was pretty much just that, a dream, right? There were these three massive barriers, seemed almost impossible to get past. But this week, it's like a perfect storm of breakthroughs. They basically shattered all three at once.
That sounds pretty dramatic. When you say three critical barriers, what are we actually talking about? What's changed now?
Okay, so first, there's a massive leap in technical capability. We're talking true human-level dexterity. And this isn't just, picking up a box. It's the precision. Handling intricate little components, sorting delicate stuff without breaking it, using tools made for human hands. And this comes from incredibly sophisticated AI that's integrated right into their physical systems.
Right. And I've seen the reports on this too. The second barrier, commercial viability. That's just astounding. For the first time, these things are actually affordable. Yeah. What kind of prices are we seeing?
That's the real game changer. Our research shows system costs are plummeting, some models now under $50,000, which is, well, it's huge. It means they're accessible not just to like the giant tech companies, but to a much wider range of businesses. It opens up whole new markets.
Okay, wow. And the third piece, which sounds just as important, is safety frameworks.
Exactly. As these robots move out of the lab, out of controlled spaces, and into, our world, there's finally been this critical mass of international coordination on AI safety standards. So getting technical ability, cost, and safety to all break through together, that's why this moment isn't just interesting, it's genuinely pivotal.
Yeah.
And this collective breakthrough, it's led to a really fascinating dual approach to the market. We're basically seeing two very different strategies emerge for bringing humanoids out there.
Okay, like what?
Well, on one track, you've got the, let's call them high-end industrial workhorses. Our analysis points to Kepler's K2, nicknamed Bumblebee, as like a prime example here. This robot is built specifically for tough industrial jobs.
Right, the heavy lifters.
Yeah. Imagine a machine, right? Runs nonstop for 8 hours on just a 1-hour charge. It can handle a payload of 15 kilograms per arm, or 30 kilos using both arms together. That's quite a bit. And it's got 52 degrees of freedom. That means incredibly fluid, precise movement, almost human-like, with 52 joints, basically. And it uses Kepler's own special actuators. These are the internal bits that give it that strength and precision. Really advanced stuff for heavy industrial work.
Okay, so built for purpose. What about the cost on that one?
So the K2, what's key there is the clear return on investment. It starts around $30,000 to $35,000 USD. So it's targeting manufacturing, logistics, places where its efficiency and strength save serious money and, improve safety. It pays for itself.
30 to 35,000. That's actually lower than I might have guessed for something that capable.
It is surprisingly accessible for that level of performance, yeah.
Okay, but then you said a dual approach. So what's the other track?
Right. So on the completely other side, you've got a strategy aimed squarely at democratizing access, spreading the tech around. And this is where Unitry's R1 comes in. And this is where it gets really interesting. This robot, its starting price is just $5,900 USD.
Wow. 5,900. That's incredibly cheap for a humanoid robot.
It's unprecedented. And it's lightweight too, only 25 kilos. Super agile, optimized for dynamic movement, interaction. It has maybe 24 to 26 degrees of freedom, so a bit less than K2, but still very capable for interaction.
So what's the strategy behind that price point? Just selling volume?
It's not just about being cheap, it's strategic. It's about democratizing robotics. Unitry offers an open SDK, support for ROS2.
Right.
Basically, they're making it super easy for anyone to build software for it. Hobbyists, students, researchers, think of it like the App Store for your phone, but for robots.
Ah, okay. So they're building an ecosystem.
Exactly. Our research team suggests this could trigger a sort of Cambrian explosion of software. You unleash potentially millions of creative people to develop applications we haven't even thought of yet. It could totally redefine things.
That is a fascinating split. The high-end workhorse versus the open platform for innovation. And it's not just Unitry on the affordable side, right? You mentioned others.
Yeah, there's also, for instance, the German manufacturer Aegis. They launched Iggy Rob. That one's around $54,500. What's interesting there is it has a wheeled base for stability, so it's another approach to cost-effective entry into factories, warehouses, shows a sort of European take on affordability meeting practicality.
Interesting. So the hardware is racing ahead. But what about the brains? The AI powering all this?
Yes, that's absolutely critical. The hardware is amazing, but it's the AI advancements that are truly unlocking all this potential. Give them the intelligence to use their bodies effectively.
Right. And we're seeing specific types of AI emerge.
Definitely. Vision language action models, or VLA models, they seem to be becoming the dominant architecture. These let robots understand and actually do things based on natural language commands, like you can just talk to them.
So you could say, hey, robot, can you grab that blue box off the top shelf?
Pretty much. And our research notes show they're getting really good at it, high faithfulness scores, meaning they understand the nuance, they get what you actually mean most of the time. It's shifting how we collaborate with machines, from rigid programming to, well, more intuitive partnership.
Okay, that makes sense for tasks. But what about the agility, the balance? We see these videos of robots doing incredible things.
That comes down to reinforcement learning, or RL, deep reinforcement learning specifically. That's what's driving the incredible agility and balance we're seeing. Like Unitry's boxing humanoids. Yeah, you heard that right, boxing. Or PND Botics Atom Robot, which can walk and balance like a person without using vision. It learns by doing.
How does that work? Learning by doing.
Through countless iterations, mostly in simulation first. Millions, sometimes billions, of virtual attempts. It lets the robot build this really robust understanding of its own body and how it interacts with the world, way faster and cheaper than real-world trial and error.
Billions. Wow. Okay, and it's not just movement, right? There's more cognitive stuff, too.
Right. Large language models, LLMs, the same kind of tech behind things like ChatGPT, they're being integrated. This gives robots higher-level thinking. They can process info from multiple sources, voice, visuals, and interestingly, they can even refuse unsafe or, like, irrational instructions, which makes interacting with them much more intuitive and, crucially, safer.
That's fascinating. AI refusing orders. I read something else amazing. AI isn't just controlling robots, it's actually designing them now.
Yes, that's another layer. Our research team highlighted this. Generative AI was used to optimize the leg design for a jumping robot. The result? A 41% increase in jump height. AI also came up with more efficient hull shapes for underwater gliders, designs human engineers just hadn't considered. So it's not just AI as a tool, it's becoming a sort of co-creator in engineering.
A co-creator. That's a shift.
It really is a truly collaborative future there. And, all this innovation, it isn't staying in the lab. It's bursting onto the global stage now.
Yeah, let's talk about that. The shift from labs to the limelight. The demonstrations recently have been pretty wild.
Absolutely. The World Artificial Intelligence Conference, WAIC 2025 in Shanghai, that was clearly the global epicenter this past week.
What really stood out from the reports coming out of WAIC?
The big thing was the shift from just like static displays, robots standing still, to dynamic real-world scenario demos. So Kepler's K2 Bumblebee wasn't just on a pedestal, it was actively sorting things, handling materials, and a mock logistics setup. And you saw Unitry's G1 in those combat-trained boxing demos.
Boxing robots, yeah. Still trying to wrap my head around that.
Right. But these weren't just tricks, they were proofs of concept, showing practical readiness.
And building on that, there's something else coming up soon, right? The robot games.
Yes. Mark your calendars. The first ever World Humanoid Robot Games, the WHRG. It's happening in Beijing's Olympic venues, August 15th to 17th. This looks like it's going to be a massive public testbed for these machines.
Okay, what kind of tests? What are the games actually designed to show?
They've structured it to test pretty much everything. 3 main categories. You've got athletic competitions, sprints, long jump, gymnastics, even soccer matches, then performance showcases, robot dances, solo and group, martial arts, freestyle sparring, and then, crucially, scenario-based challenges. Things like material handling, sorting drugs in a pharmacy setting, hospitality tasks, real-world stuff.
And I heard about the soccer match, 3 versus 3, fully autonomous.
That's the big one. 0 human remote control. The robots have to perceive, decide, and collaborate entirely on their own in real time. It's a huge test of their embodied AI, like a live stress test of their real-world smarts, right out in the open.
That sounds intense
Oh,
and stressful for the creators, I
oh,
bet.
definitely. But these games also serve another purpose: ecosystem development. They're building a talent pipeline from universities down to high schools. Setting these tough R&D goals forces everyone to solve real problems.
Intense. And beyond the practical, there were some, well, almost symbolic examples too. Robots stepping into very human roles.
Yeah, our research team flagged a couple of really interesting ones. Get this. A humanoid robot officially enrolled as a PhD candidate in drama and film.
You're kidding. A robot PhD student.
Not kidding. And P&D Botics' Atom robot performed on stage with a live band, playing a guitar, apparently. It shows it's not just about efficiency anymore. It's about integration into, well, the fabric of our lives, blurring lines we thought were pretty solid.
A guitar-playing robot PhD candidate.
Uh-huh.
Okay. The future's definitely getting weird. So pulling this all together, what's the broader impact? Where are these machines actually going to be used first?
Right, the applications. Our analysis shows an explosion of uses, starting pretty much now. Obvious first stop is industrial automation, manufacturing, logistics, warehousing, taking over those dirty, dull, and dangerous jobs. Addressing labor shortages, improving safety. We're seeing trials already. Amazon, BMW, Hyundai, big names are experimenting.
Okay, industry makes sense. What else?
Healthcare is another big one. Medical assistance, maybe sorting and packaging drugs accurately, and then service and commercial roles. Think hotel concierges, room service, maybe public maintenance like cleaning or security patrols. Their versatility is key because they're designed for human environments.
Which brings up that core argument, right? Why humanoids? We already have specialized robots for specific tasks. Why build something that looks like us?
That's a really important question, and you see a lot of debate. But the core insight from the research seems to be about generality and adaptability. Humanoids are designed to work in our world, use our tools, without needing expensive, custom infrastructure changes. So it's a strategic bet. One adaptable platform that can do many things versus needing lots of specialized, single-purpose robots. Sort of like the smartphone model versus having a separate camera, map, music player, etc.
Okay, the adaptability argument. That makes sense. Something else that's clear is the geopolitical angle. This isn't happening in a vacuum.
Not at all. It's playing out right in the middle of that intensifying US-China tech rivalry. Our research definitely highlights China's very concerted state-backed push. They want to dominate humanoid robotics by 2027. They've got ambitious market projections. And these coordinated events, like WAIC and the WHRG, they're clearly part of a larger national industrial strategy, aiming for that leading position.
So it's a race, a technological race driving innovation globally.
Absolutely. Pushing the pace maybe even faster than it would otherwise be.
Okay, this is fascinating stuff. And if you at home are finding this insightful, please do take a moment to like this video, subscribe here on YouTube to Tomorrow Unveiled, and definitely turn on those notifications so you never miss an update on the future.
Now, despite all this excitement, and it is exciting, we should be realistic, there are still some significant hurdles to overcome.
Absolutely. Need that realistic outlook. So what are the main challenges still?
Well, on the technical and supply chain side, things like battery life, it's improving, but still a limitation for some demanding uses. Potential bottlenecks for key components, like those advanced actuators we mentioned, getting enough of them reliably, and then just long-term durability. Ensuring these things can actually hold up day after day in messy, unpredictable, real-world environments, that's a big test.
Yeah, the lab is one thing, the real world is another. What about the software side?
Right, software and AI robustness. Generalizing manipulation skills, teaching a robot to pick up any object, not just specific ones, that's still hard. Dynamic balancing on, say, uneven ground outdoors, still tricky. And just ensuring safe, predictable interactions when things get chaotic. That's a huge area of ongoing research. Teaching a robot to dance is one thing. Having it navigate a busy sidewalk safely is another level entirely.
And the economics. You mentioned prices are dropping, but
But economic viability is more than just the sticker price, right? It's the total cost. Buying it, integrating it, maintaining it, maybe training staff alongside it. That whole package needs to offer a compelling ROI, especially for smaller businesses, before we see truly widespread adoption. It's getting there, but still a factor.
okay, so technical challenges, software robustness, economic viability. What about the societal impact? Jobs, ethics.
Yeah, the big questions. Looking at the societal implications, The general feeling in the industry, which our research seems to back up, is more about complementing human workers, taking over the really mundane, repetitive, or dangerous tasks, augmenting human capabilities rather than outright replacing everyone. That seems to be the goal, or at least the narrative.
We'll see how that plays out. And ethics.
Yeah.
Safety.
Crucial. As these robots move into public spaces, we absolutely need clear guidelines, regulatory frameworks. Who's liable if something goes wrong? How do we ensure they're used ethically? Privacy concerns. These are really important conversations that, frankly, need to happen alongside the tech development, not after the fact.
Definitely. Keeping pace is key. And hey, if you're listening to Tomorrow Unveiled on a service like Apple Podcasts or Spotify, we would be incredibly grateful if you could leave us a rating and review. It genuinely helps us reach new listeners.
We also love hearing what you think. Whether you're on YouTube or your favorite podcast app, drop a comment. Let us know your thoughts on this rise of the machines.
So let's wrap this up. To summarize, this past week, it feels like a real turning point. Groundbreaking unveilings, these jaw-dropping demos, the deeper AI integration. It all confirms that the era of the humanoid robot. It's truly beginning. We're seeing this incredibly rapid acceleration from research labs into, well, reality.
Yeah, the feeling is palpable, and it leaves us with a big thought, doesn't it? The question isn't really if humanoid robots will become a major part of our industrial world, maybe even our social landscape. It seems like that's happening. The real question now is how quickly, and maybe more interestingly, what new kinds of human-robot collaboration will emerge? What will daily life look like when these machines really are commonplace?
A fascinating question to ponder. Thank you for joining us on Tomorrow Unveiled. Keep a close eye on the future of robotics, because how the market reacts to these first commercial humanoid robots, that's going to be the real test of this, well, this potential new industrial revolution. We'll see you next time.